Okay, so first of all, I want to point out if you have 2 to the negative 3, then really what you're trying to do is rewrite without So yesterday we talked about the idea that if you're looking at 2 to the negative 3, that's really like a fraction over 1. And so you want to move that so that this becomes a 2 on the bottom with a positive 3, and then you fill up the empty space with a 1, right? And so then today we're going to talk about what does that equal? And so since we don't know how to evaluate a negative exponent, we do know how to evaluate a positive exponent, because 2 times 2 times 2 is a number. It's 1 over 8. So that's what this equals. So I can flip the exponent to change the sign. Base never changes. So that's going to be true this entire unit. The base is never, ever going to change. But the exponent can change. That's what we're trying to simplify. Simplify exponents. So exponents can change, bases never do. All right, let's go over to the problem on the right side of your screen. So 4 to the negative 3 power. First of all, problem, negative exponent. First step, get rid of negative exponents. So that's what we learned how to do in Wednesday's lesson, is how to flip this over so that it is not negative anymore. So if I move this parent into the opposite room, my baby becomes positive. So I flipped my exponent over to the denominator, and negative 3 became a positive 3. So really, this is the same as saying 4 times 4 times 4. Because we don't really know what negative 3 means, but we do know that positive 3 is multiplying 3 times. And so I end up with 16 times 4, so 1 over 64. So if I'm typing this in, 1 divided by 64. Yeah. All right. Problem number 2. 3 to the negative 2 power. So first thing, I'm going to flip it. 1 over 3 to the positive 2, and then 3 squared is 9. So 3 times 3 means 1 divided by 9. 2 to the negative 1. So I'm going to put this over a fraction. It's 1/2. So 3 times 3 is 9, and then 3 times 3 is 9. So 9 times 9 is 81. So 1 over 81. We've done this one before. So if I have a negative exponent, I'll move it down to the bottom to make it positive. And then 2 times 2 times 2 is 8. 1 over 8. Next problem, 4 to the negative 2 power. If this is over 1, I'm going to move it down. 1 over 4 squared, which is 1 over 16. Eight to the negative 3 power. So I'm going to put that over 1. Move it down to the bottom. So 1 over 8 times 8 times 8. I would like to point out at this point in the work that if you're using a calculator, I feel like that's completely fair. You're in 8th grade. You know, we're not practicing multiplication anymore. We're practicing exponents. So if you're trying to figure out what 8 times 8 times 8 is and you need a calculator for that, that's fine. So I just used my calculator to figure out that 8 to the 3rd power is 512. So I know my answer here is 1 divided by 512. So I think that calculators are completely fair when you're headed into high school next year. All right, moving on. 1 over 4 to the 4th. 4 times 4 times 4 times 4, 16 times 16. You may not know, but I do, because I have a math degree and I've practiced this so many times it's painful. 1 divided by 256. Okay, 1 to the negative 2 power. So again, don't let the idea that it's so simple throw you off. 1 is over the fraction 1, and so I'm still going to move it down, and I still end up with a 1. 2 to the negative 4th power. So if I move that down, it becomes 2 to the positive 4. And 2 times 2 times 2 times 2 is really the same as 4 times 4, right? Which is 16. So 1 over 16. So I'm up to a smart score right now of 72. So let's keep going. Almost there. 9 to the negative 1 power. So again, if I put that over 1, move it down, 1 over 9 to the positive 1, which is the same as 1/9. All right, this is where things get a little tricky because we haven't talked about this yet. If you have a fraction raised to a power, then really this fraction is raised to the same power in the numerator and the denominator. Which, if you have a 1 here and a 1 here, because that's always invisibly what you have, then really this equals 1 to the negative 2 over 3 to the negative 2. So 1 times negative 2 makes that, and then 1 times negative 2 makes that. But the problem is if you think about that example of like parents with a cranky baby, this parent has a cranky baby in the numerator, and this parent has a cranky baby in the denominator. So realistically, both parents just need to switch places. And then suddenly no more cranky babies. So 3 squared is 9 and 1 squared is 1. So this is really 9 over 1, which is just 9. So let's try another one of those. So 1/8 to the negative 1 power. So really I need to take this and multiply it in to both bases. So I have 1 to the negative 1 over 8 to the negative 1. And then this needs to move to the bottom. This needs to move to the top. So 8 over 1, which is just 8. And there we are at a smart score of 81. So let's take you one problem further just to make sure. So I'm going to multiply that in to both numerator and denominator. And then I need to swap them around. So 16 All right, we'll see if you can get farther than that on your own. Good job.